Hey guys, it's Max, and we're back with Battlecode 2016. In this video, I'll make a little demonstration of how messaging works this year, which is also a helpful way to select a leader for your team. Let's get right to it. At the beginning of the run method, I'm going to make some code that's specific to Archons alone. We're going to elect a leader Archon using the messaging system, and I'll show you a really quick way to do this. All you have to do is the following. Let's check if our robot type is equal to robot type.archon. Okay, so only Archons are eligible to become leaders in our example. Next, let's check to see if it's round 0. In this example, we're only electing a leader on the first round of the match. In reality, you might need to elect a leader again if the leader is destroyed, but we'll cover that probability later. So let's check that rc.getRoundNum equals 0. Getting the round number can be a useful way to generate pseudo-random numbers. But here we're just going to check if it's 0. Next, what we'll do is we'll read all incoming messages. This is going to make sense in a minute. Message types are signal, and we want an array. We'll call it incoming messages equals rc.emptySignalQueue. That'll get all the signals that have been sent from allied and enemy robots since I last emptied the signal queue. And since this is the beginning of the match, it'll just do it since the beginning. Now we're going to check the length of the incoming messages. So let's do the following. We'll set the indicator string of the robot so that we can see in the client what this value is for each robot. You'll see what I mean. We're going to set indicator string. There are 3 of them, so I'm going to set the 0th, or the first indicator string, and I'm going to set its value to the following. I use an empty string, which is a pair of quotation marks here, followed by a plus, and then I can type incoming messages.length plus, and then another string, and I'll call this messages received. And this will add this together into a string that's more human readable. So right here, it'll put the number of incoming messages. Okay, the last thing for me to do is send messages. So I'll do rc.broadcast message signal, and it takes 3 arguments. The first 2 arguments are the special integers that are sent along with my robot's location and ID. And the third argument is the radius over which to broadcast in square units. So I'm going to broadcast 10 tiles away. The larger distance you broadcast, the more bytecode it requires. So that's something to keep in mind. Since generally our Archons start out bunched together, they're all going to receive these messages. It's interesting to consider that in the event that your Archons do not start out bunched together, individual packs of Archons are actually going to have separate leaders, just because of the distance of the message signal broadcast. So you can specify what distance means you have a different pack of Archons. And this is really cool. It's like emergent behavior. All right, I'm going to push save, and then I'm going to run, and you're going to see the effect here. Now, if all the robots executed simultaneously, then they would all receive the same number of messages. In fact, they would receive none, and then they would all broadcast the messages, and then if they read those messages the next turn, they would all receive the same number. But in fact, robots execute sequentially. So the first robot that executes will see no messages available. The second one will see the robot from the first robot. The third robot will see from the first and second, and so on. So if we rewind the match back to the beginning round and go to just the first round here and click on the Archon, this Archon says 0 messages received. The one next to it says 3, 4, 5, 1, and 2. So you can actually see the execution order just like that. And it would be absolutely trivial for me to set this Archon, who's received 0 messages, to be the leader. All I would have to do is define a local variable and say if my message's length is 0, then I am the leader. Subsequently, everybody else can pay attention to this robot, who will be the only one broadcasting message signals to the entire army. And that's one really easy way to use messages to elect a leader. In the next video, we might use those message signals to direct the motion of the army so that everybody can move together in a coordinated manner. See you then.